Yeah, good evening, everyone. Everyone is able to hear me? Yeah, just a couple of minutes. I'll be waiting. I'm waiting for others to join. Yeah, so just 2 minutes. I'm waiting for others to join. Then I'll start the session. Today is not first class. Today is, I think, 10th class, I think. I think we already completed 8, 9 classes. We completed already 2 unit. Today we are going to cover. Actually, yesterday I was not actually, I was not available yesterday. So today I'm going to start new tool, which is Maven. I'm waiting for others to join so that I'll start Maven. I'll upload the notes. Yeah, today I'll upload. Okay, I just sent you all this. Right? Google Classroom link also, I think already I sent. Everyone has got the Google Classroom link and earlier videos. Right? Everyone got right? Okay, then. All right. So welcome to the new tool. Already we completed 2 tools. Already we completed 2 tools. All right. All right. Let us now talk about another tool called Maven. Already we gave one touch to Maven, right? Already we have touched Maven in the last 2 tools. See, we studied till now JUnit and Mockito. We studied JUnit and Mockito. So already, okay, already actually we have seen the flavors of Maven here. I showed you, but I told you that we'll be seeing Maven as a separate tool. Okay, I told. Okay, so basically, so for example, I have now one what you say is suppose I have a project actually. Okay, I'm building a Java project or creating a Java project. Okay, so assume that, imagine that there is no Maven. I'll tell you what is Maven, but imagine that there is no Maven. Okay, so imagine that, sorry. Imagine that there is no Maven. Imagine that there is no Maven. Right? Say, for example, we are creating a Java project. Say this Java project is having, say, we are creating this project with 100 Java files. Okay, so there are some 100 Java files. With 100 Java files, this project is being developed. Okay, and we are also using some third-party libraries. Third-party libraries. Okay, in this project. Okay, where this third-party libraries like what are the different third-party? Like example, we are using Spring Framework. Okay, Hibernate. So these are some third-party libraries. So example, these are third-party libraries we are using in our project. Right? Okay. And in these 100 Java files, whatever we are writing, say some of the Java files will be using like import packages, right? Import warg.hibernate.star, right? Next is okay, import, okay, warg.spring-hibernate.jar, okay. Similarly, warg.spring framework, warg.spring, okay, spring framework, something like this. So we are using these packages somehow. Why we are using? Because actually Hibernate is especially mainly for the database related part, database related, all your, it is called ORM actually, object relational mapping. Okay. And Spring framework we are using for different purposes like MVC, Spring Boot. So we are using this. Similarly, not only this, say we have seen JUnit and Mockito, right? So for example, even these are also third-party libraries. So JUnit, Mockito. Okay. So these are also third-party libraries used for unit testing. And I told what is the difference between JUnit and Mockito already, right? And that is the reason if you see these JUnit and some, see when I type speedly, I'll get some typing mistakes. Okay. Don't bother about that. JUnit, right? So what will happen, So this JUnit and used for unit testing, and in our test code, we might have seen like this, right? Remember? We open this. So if I open this, so in my test code, I will be using like this. If you see here, warg.mockito, warg.junit Jupyter. So, okay, I'm using this packages, right? Why? Because I'm using the methods related to these classes here, mock method. Okay, so I'll be importing this. If I want to use any third-party library methods, means I'll be importing those packages here. Okay. Okay, like that. Actually, my 100 Java files will be using these libraries for developing this complete Java project. Okay, fine. Now how these libraries will be coming now to your project? See, these 100 Java files you will be writing these, but how you will get this this Spring Framework libraries, your Hibernate libraries, JUnit libraries, Mockito libraries? You have to download them, right? So, say you developed a project, you are developing a project. Okay, you have what you have done. Project means it is a folder somewhere in your C drive or D drive, right? In C drive or D drive, you create a folder. You create some my project folder, right? My project folder. In that my project folder, under this folder there will be sub packages also, subfolders. In Java, every class will have a package, right? That package means it is under subfolders, right? Subfolders. Under each subfolders, you will have the Java files, okay? .java files. So you have C drive, D drive, under so my project folder, subfolders. Under that you have .java files, okay? Now, what we have to do is we have to download all these third-party libraries also, okay? Whichever project we are using, so we have to download them. We have to log into the Spring Framework website. We have to log into Hibernate website. We have to log into JUnit Mockito website, and all these libraries will be having jars. So like we need to download all the jars. So download all the jars. Okay, all the third-party jars. Okay, from the respective websites, right? And then where you have to put all these jars, where you have to download all jars, you have to download all these jars and put in this folder, right? You should create one folder called jars folder, and under this jars folder, you download all these jar files and you place here. Okay, under the jar folder you have the Spring related jars. Okay, next Hibernate related jars, right? JUnit, Mockito related jars, right? Like this. All right, so fine. Now when you compile this, now you have written .java files. Now you have jars folder. Under this you have all these jars. Now what is the next step you have to do? You have to compile, right? So the next step you have to write is, so the next step you have to write for all these .java files is, so you have to compile like Java-C. Either you have to compile at the package level or at a folder level. You have to compile. And while compiling, you have to include these jars also in the class path, right? You have to give class path and you have to give jars. All the jars you have to refer in the class path. And then you have to compile the files. You have to compile the files. You cannot give star.java. You have to compile like, you can use star.java also, but if suppose those Java files are in different folders, you have to go to each folder and then you have to give star.java and then you have to compile this. And what actually, when these Java files gets compiled, what happens now? They will take the jars from this class path, and wherever these classes are using these third-party libraries import statements, all this gets compiled. Otherwise, if you don't include these jars in the class path, so these classes, these import statements will be unrecognized. Whatever you're importing these, they will be unrecognized and you'll get compilation errors. Okay, you used to do that. Now, finally, finally, all the .java files got converted to .class files. Okay, after this command, all the .java files got compiled to .class files. Okay. Now I'm making this as one project actually. Okay, I'm making this as one project. So what I have to do for a project means all these .class files, again, I can bundle. I can package all these or bundle. Package or bundle as one jar file. Suppose if it is a web application, we say one war file. Suppose that web application is having JSPs or servlets. Okay, so that is for war file, web application. So like that we'll bundle. See, do you think this is simple task? No. This is not at all a simple task actually, whatever we are doing. See, writing 100 Java files, that is in your developer task, we have to write it. But then downloading all the third-party jars from the respective websites and putting that under jars folder, okay? Then compiling all these files like this, and again bundling all these class files into one jar or one var. This is not a simple task. This requires a lot of effort, manual effort to be done. You know, this we used to do almost some 18, 20 years back. So this type of work we used to do 18, 20 years back. Okay. So lot of work used to be there here. Okay. See how many jars I will download from the third-party websites. I'll be using so many jars. Okay. Spring framework itself is having almost like if I include one Spring MVC library, Spring MVC library is having like 4 or 5 jars. Hibernate itself is having some 5 or 6 jars. Okay. JUnit Mockito. If you see Mockito only, Mockito itself, I'll show you how many jars we have. See how many jars? 1, 2, 3, 4, 5, 6, 7. See all these jars. See, we used Maven dependency, that is different task. But if you go manually, we have to download all these jars. Maven and JUnit Jupyter, sorry, JUnit and Mockito itself is having around 10 to 12 jars. We have to download all these jars, set in the class path, and compile all this. So to eliminate these kind of things, this is where your Maven has come. So this is where Maven simplifies all these tasks, whatever you're doing, like downloading the third-party jars, adding that in the class path, compiling that files, again packaging that into one jar or one var file. Okay, all these Maven simplifies the task. So that is why Maven is called build tool. So Maven simplifies the above mentioned process. Okay. So Maven simplifies the above mentioned process. Okay. So with the help of Maven, okay, we can download the required third-party jars, third-party libraries. Okay. Set in the class path. Next, compile the Java files. Okay. Next, package all these compiled files into jar or var file. All this will be done by Maven in a easy way. That is the reason, if you see, for our JUnit or Mockit also, did we downloaded these jars? No, we did not downloaded these jars. Just we specified in pom.xml these dependencies like this. Okay, I'll tell you what is this dependency and all that when I explain you, when I go Maven in-depth topic. So just we specified these dependencies like this. Your Maven only downloaded all these jars. See, all these jars I did not downloaded. I did not show that I downloaded. Just I added this. Automatically these jars got added. You see, automatically these jars. See how many jars? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14 jars. So just with 3 dependent. Okay, 1, 2, 4 dependencies I added in Maven. So 14 jars got downloaded. Okay, I'll tell you what is this dependency and all that. So Maven simplifies the task for us. Okay, so Maven simplifies the task for us. Okay, so that is called, Maven is called build tool. So what is a build tool means? What is a build tool? Build tool is nothing but the tool which is helping for building a project. This is called build tool. Okay, the tool which is helping for building a project is called build tool. Okay, so Maven simplifies all this process. Okay, this is what Maven. Now we are going to see the topics in the various topics in Maven, how Maven will download the third-party libraries, how Maven will set in the class path, how Maven will compile the Java files, how Maven is going to package all these into jar or var file. All these we are going to see. Okay. Now let us take Maven is a build tool. Maven is a build tool. Okay. First step. Okay, Maven is a build tool. Just 1 minute. Just 1 minute. I'm getting one message. Just 1 minute. I'll attend this message and just. Yeah, sorry, I got one message. I got one message. Okay, fine. Okay, Maven is a build tool. Okay, what are the important tasks that Maven does? The important tasks that Maven does. Okay, first one. See, just follow this carefully. Building or creating a default project structure. Okay, using Maven templates. Okay. So when we say default project structure, remember, if you remember in Eclipse, when I created JUnit project, remember I told you we'll go to File, New, Maven project, and click on Next, and I select this template, Maven archetype quick start. Okay, these are the templates. Okay, so Maven is having different templates. So what will happen is, suppose if I use Maven archetype quick start, so what this will do is, so this will create basic code structure for standalone Java projects. Suppose if I use Maven archetype web app, this will create basic code structure for web applications. So we have two different types of projects. One is standalone project. Standalone means without any web application, without any servlets or without any JSPs. Those are all standalone projects. That means they can run without server also. Web applications means they need a server. They have to run in some server like Tomcat server or some application server. Okay. So this will create basic code structure for web applications. Okay. Now I told you, right? So suppose I think I told this when I explained you JUnit. Okay, but again I'm repeating. Suppose I create a project like this, Maven archetype, quick start. Okay. Then I create this template. I select this template. Then I enter group ID artifact ID. I told you this group ID artifact ID also in when I told you JUnit, but I'm going to explain this. What is this group ID artifact ID? Remember, I told this group ID artifact ID version also. But anyway, I'm going to tell you that. And I click on finish. I get one basic product structure. I get one basic project structure like this. Okay, like this. I think I showed you this actually. Remember, I explained you this when I was explaining the JUnit. So I get a basic structure like this, where this is the artifact ID. This is artifact is nothing but the project ID. And under this project, there is a main Java folder. Under main folder, you will write all the files which are required for your business logic. And there will be one more folder, which is a test folder. Under test folder, you will have test files where you will write all your JUnit and Mockito code. I mean, the same is getting reflected here like this. I mean, this is under this package. Now here I'm expanding this like a folder structure. Okay. And in addition to that, we have one pom.xml. We have one pom.xml. I explained you this, right? Remember, when I explained you this Maven basic project structure, right? Right? Yes. So Maven will create a basic project structure like this. Okay, this will create a basic project structure. Okay. Now, second one. Yeah, just watch my recorded videos. I shared you all recorded videos. In that I explained all these actually. Okay. Second one. So Maven, what are the important tasks? This is one thing. What is second one is? Second one is Maven. Maven downloads the required dependencies specified in pom.xml. Okay. Specified in pom.xml. Okay. What is this pom.xml? I'll tell you. Okay. This is a very important file in Maven. I'm going to explain in detail of this pom.xml. Already in JUnit Mockito, I have showed you pom.xml, where I specified these dependencies like this. But I'm going to explain in detail what are these dependencies. Okay. Next, the third one, Maven compiles all the .java files into .class files. Right. Next, bundles or packages into .jar or .var file. Okay. This is one thing. Then what is the next what is the next one is Maven handles versioning of artifacts. Okay. I'll tell you what is this versioning also. Okay. Next is Maven generates documentation from Java source. Next one is, okay, Maven also has integrations to many plugins. Okay, where these plugins are helpful for different tasks. I'll tell you these plugins, very important things. For example, Maven has plugins. Maven has different plugins. Okay, these plugins are nothing but some utilities where, for example, I want to determine the code quality. Okay, how the quality of the code is there. So Maven has a plugin called Sonar. Sonar plugin. Okay, where with Maven we can determine the code quality. Sonar is also one tool that we have in the coming sections to determine the code quality. Okay, so like that, Maven is having different plugins. For code quality, we have one plugin. Okay, for generating documentation, we have one plugin. I'll tell you all these plugins. Okay, important plugins. So like that, Maven is used these type of scenarios. Okay. Now, let me tell you about the various building blocks of Maven. Okay. So now you got an idea about what are the different tasks Maven does, right? It will create a basic code structure. It will download the required dependencies. It compiles all the .java class files into .class files, bundles or packages into .jar or war file. Maven handles versioning of artifacts, right? Maven generates documentation from project source code, right? Maven also has integrations to many plugins, where these plugins are helpful for different tasks. Now, let me now tell you about the basic blocks of a Maven, okay? The basic building blocks. So in Maven, the first building block is called group ID. Okay. Then the next building block is artifact ID. Artifact ID. And the next building block is version. See, that's why when you select in Maven one template, remember, I go to my Eclipse, file, new, I create a Maven project here. I click on next. I select this archetype, so this is a template, okay? Now I click on next. It will ask this group ID, what group ID, what artifact ID, what version. These are the building blocks, okay? So these are required for generating a default project structure. Okay, after specifying these values, I click on finish. Maven will generate a project structure like this for you. Okay, so what is this actually group ID means? See, this group ID is nothing but a group which holds multiple projects. Okay, so group means it holds or contains multiple projects. Okay. Group means holds or contains multiple projects. Artifact is nothing but the project. Artifact means it is a project. It is a project. Under version means, I told you this when I explained with JUnit also, but I'm explaining it. Version means the version of the project. Okay. Now let us now think about, I'm just giving one practical example. Now I have an organization. I have an organization. Okay. So this organization, say, okay, this organization is say, let me tell what organization I can have. What organization? Okay, let me think like any kind of some company, something like let us think like yeah, I think yeah, we can give pieces or something like okay, like something like Samsung. Okay, but you know, Samsung mobiles are not that much popular, but they used to be popular earlier. Still, I'm using Samsung mobile only. So let us think Samsung organization. In this, So one is like mobile group, right? And another you have like okay, another you have like a television group. Another you have like kind, right? So right, and then you have another group like something like Samsung refrigerators also, right? Refrigerator group. Yeah, your tablet also, yes. So under this mobile group, Samsung tablet is also there. Yeah. So under this mobile group, now you'll have like kind of uh, like you have kind of models, right? Uh, Under this group, there will be multiple projects, we can say. Each project will be having, for example, let me take like there are different projects, okay? Like Samsung Galaxy, right? And there might be another project like something like Edge is there, something like. So now under Galaxy, there will be multiple versions. So there will be multiple versions, something like A1, A2. Okay, there might be multiple versions like A1. The older versions are there, J2, J7, like that. There are so many versions, right? And similarly under Edge also, if you see, there are so many versions, right? Under television group also, you have some kind of different products coming, right? And under this, there will be versions. Okay. Now, if you see, this is a group. Under group, there are multiple projects. These are all projects. Under each project, there are multiple versions. Okay. Under group, there are under group, there is an artifact. There can be multiple artifacts. Under artifact, there can be multiple versions. What do you mean by version actually? Suppose I developed one project with initial version. Okay. Suppose a project is developed with initial version. Has been developed with initial version. Okay. Some new features came to this project. Some new features came to this project. So now this version will be, now a new version will be created. A new version will be launched with a different version number, right? If you take mobiles also, like new features comes, they will come with a new version. Okay, but the product is same, but the versions keep on changing. So that is called versions. So every project will have a version. Now, if I take from the realistic example, another example I'll tell you, one which is close to this example. See, there is an organization called Spring Organization. Spring Organization, which developed the Spring framework. And this is the popular Java framework, right? Under Spring Organization, there is Spring Core. There are two groups actually. There are so many groups, but I'm putting two groups now, just for simplification. Spring Core and Spring Boot actually. Okay. Spring Core and Spring Boot. Okay. Now these are groups actually. Okay. These are groups. This is one group. This is one group, group one. And this is another group, group two. Right. Now under this group, there are multiple artifacts. So one artifact can be Spring Context. Okay. Okay, Spring Context. Okay. Under this Spring Context, there will be multiple versions. Version 5. Okay, version 5. 5.1. 5.2. Okay. Like this. Okay, under Spring Boot, we have different like under Spring Boot, we have different artifacts like Spring Boot starter parent, right? Under this, we have versions, version 2.7, 2.7, like that. We have different. See, the Maven project. So this is your Maven group. Under this group, there can be multiple projects. Under this project, there can be multiple versions. The project is nothing but the actual code, where the code will be there. So the project is nothing but the actual source code. Source code is present in the project. Okay. And the source code will differ from version to version. This version will have one source code, and this version will have some updated source code. That means it will take the same source code, but some new files or some updated files might be there. So version to version, the source code differs. Okay. So this project is nothing but your artifact ID. So that's why your Maven will create the project with the artifact ID name. See, whatever the artifact ID that I give, so that will be your project ID here. So that will be your project ID. Okay. Now, if you see here, so once I create a Maven project, now it will create in the pom.xml like this. You see, suppose let me create one simple Maven project file. I'm creating a freshly new Maven project. I click on next. I select quick start template. Now I give some group ID as some group ID like my what you say is my group one. I'll say I'm creating one group called my group one. An artifact ID I'll create as my new app or something like my new app. I'll give on artifact ID, and I'll give a package. I'll tell you what is this package. So package means the default Java package that will come. Now you click on finish, Now if I click on finish, you see if folder structure has created with my new app. You see at the bottom, my new app has been created. So this is what we call the project artifact. Okay. Under this, if you see in pom.xml, this has been generated automatically. Whatever we have given there while creating the Eclipse. So the same thing has come. The group ID is my group one, artifact ID is my new app, and the version by default it will come this version. We can change this if you don't want. I can use this version. Okay, but Maven will come default with this version. See, this version indicates that snapshot means it is a development version. Still, this version is being developed actually. Okay, and this is the jar packaging jar. That means this entire project is going to get packaged to a jar. If I don't want jar, I can make this as var also. Suppose if it is my web application, I can make this as a var. So Maven, what it does, I told you, right? Maven, one of the tasks, it compiles all the code and bundles into jar or var file. That is called packaging. So if I say jar means it bundles all this into jar, one jar. already this I told, one task I told. Okay, if you see here, Maven compiles all the .java files into .class files. Bundles are packed into jar. And how this is possible? Here I will be specifying packaging as jar or war file. So accordingly, Maven will bundle all the project files into jar or war file. So this is what created now. Okay. Suppose tomorrow one more Maven project under the same group, under the same artifact ID, but it can be a different version. Okay, it can be a different version. So I can have like this. So now I have a group one. Now I can have artifact ID one. Artifact ID one. Under artifact ID one, I can have version 1.0. Right? Next, we can have version 1.1. We can have version 1.1. Version 1.1. So I have a group ID. Under a group, I have artifact ID one. I have version 1.1. Okay. Now, if you see, this will be one jar file. This will be packaged into one jar file. Say the name of the jar is artifact ID 1.0. 1.0.jar. Artifact ID 1. So this can be packaged to another jar. Artifact ID 1.1.jar. That means it will take the name of the artifact and the version attached here, .jar. It will take the name of the artifact and the version attached. So this will be one jar file and this will be one jar file. What is the difference between these two? So this is the older version. So this is the older version. Older version. Okay. So this will be the latest version, new version, which contains updated Java files version, which contains new files, new code components and all, etc. Okay. Now under group, I can have one more artifact ID 2. This is another project. Under this artifact ID 2, I can have version 1.0. Now when I build this project, so I'll get here artifact ID 2 hyphen 1.0.jar. So where I specify to Maven to generate all these files to jar. Say this version 1 contains say 100 files, 100 Java files. Okay, this version 1.1 contains some new files added, some 110 Java files. So where I specify this to be made to jar? In my packaging section. In my packaging, I'll put this as a jar. So if I put this as a jar, so now all these 100 Java files, your Maven will compile this to .class files and bundle this to jar. All these 110 files will compile this to jar. Any doubts till now? Any questions, any doubts? Okay, Monday will continue. So Monday I'll be telling you some in-depth parts of this Maven and all. No, it is not automatically connected to jar. No, there are some steps. See, now I created a Maven project. I have to do some tasks to make this to jar. I'll tell you this. We have to run some commands to create jar. Those are all called Maven commands. Those are called Maven commands. And if you use the Eclipse latest version, if you use the Eclipse latest version, if you use Eclipse latest version, Maven plugin is already there in Eclipse. Maven plugin is already there in Eclipse. So that's why in Eclipse, you can see file. When I say new, you can see Maven project. The old version of Eclipse will not have this. The new version of Eclipse will have this. Maven project, select this. I'll tell you, I'll show you how to import Maven project. I'll show you. Then why we are specifying jar in dependency in pom.xml. We are telling Maven, see, there is one command in Maven. When we run that command, Maven will look the packaging type that we specify in pom.xml. Whatever we specified, whether it is jar or var. So when we run that command, if it is jar means it will bundle into jar. Suppose if we specify var means it will bundle into var. That means we'll specify one Maven command. So when we run that Maven command, Maven will look in the pom.xml what packaging type we have specified. So if we specified jar means it will, when that command gets executed, it will bundle into a jar file. It will package all into a jar file. Otherwise, it will package all into a var file. So that is the reason in pom.xml we have to specify. We have to specify in pom.xml what packaging we need. If you don't specify any packaging here, by default, it will be jar. So by default, it is jar. Any doubts till now? Any doubts or any questions? Everyone clear? So Monday will continue. So Monday will continue the other. Okay, we'll continue like how Maven will download this one. This part we'll see. We're going to see how Maven will download the required dependencies specified in pom.xml. Okay. See, if you need to contact Supriya madam for the classroom full, just contact madam. I'm giving the number. Just note it down. And these are the video links already sent. Again, I'm sending these 10 days links. Take down. So contact Supriya madam for the Google Classroom link. What? Okay, I'll upload this in Google Classroom link. So Monday we are going to see very important topic, how Maven is going to download these dependencies in pom.xml. What is this? Okay, I'm going to tell this actually. Okay, this part. All right, then. See you next. See you Monday. Okay. Tomorrow there is no class. See you Monday. Okay. Thank you all. Thank you everyone. Okay. Okay. Don't miss my class. I request everyone to attend the class. If you miss the class, you will lose a lot of information. Okay. Everyone, I request to attend the class. Okay. Then thank you all.